Good morning, children. In this video, we will be discussing functional groups. It's a part of content-based experiments, practicals, class 12. So please prepare this well. So you have 30 marks practical, right? Out of the 30 marks, salt analysis, which is also called as qualitative analysis. You will get for 8 marks. That is must. Okay. Then the second experiment which is must is volumetric analysis. Volumetric analysis, which is also called as quantitative analysis. Even this is given to all. So 8 marks here. Okay, and you will have one content-based experiment. In content-based experiment, one of the experiment can be functional group. You can be given foodstuff experiment, chromatography. Okay, so since I'm talking about functional group in this video, I'm writing that this would be 6 marks. So if you add up, this comes out to be 22 marks. Okay, this comes out to be 22 marks. And the remaining 8 marks you will have practical file, project, your practical file plus your viva. Okay, that is 4 plus 4. So total 8. And then that makes it 30 marks. Okay, so 3 experiments each student has to perform. Volumetric, salt, and one of the content experiment can be functional group. So here there can be a choice that is given by the examiner. Okay, so please prepare this well. So now let's start with the functional group. So when you are given a functional group, what you will do is you are going to follow a particular sequence. Like the first functional group which you are going to try for is alcohol. You will try for alcohol functional group first. Okay, so what is a test for alcohol? So I'm telling you the confirmatory test. Actually, for each one there are 2, but for one or two functional group there is only one test. So functional group alcohol. Alcohol is OH. Okay, it's actually acidic, but that we do not perform because even carboxylic acid is acidic. Phenol is also acidic. So the test which you can perform for this is one is CAN test. That is ceric ammonium nitrate test. Ceric ammonium nitrate test. CAN test we call it as ceric ammonium nitrate test. So what you will take is, you will take this sample, that is alcohol. You will take sample and to that you will add CAN. When you add it, you will get red color. It's not actually red color. The color of this CAN is slightly orangish yellow type. So when you're adding, you can see in that solution reddish tinge. Okay, so appearance of the reddish tinge confirms that alcohol is present. Right, this is first test for alcohol. The second test for alcohol is ester test. Ester, that is fruity smell will be obtained. Okay, this was the first test and the second test is ester test. Now how we perform ester test, let's take that. You will take sample. Here sample is alcohol. You will add to this a little quantity of acetic acid. Acetic acid you are going to add. And then few drops of sulfuric acid. Few drops of dilute sulfuric acid you will add. And you are going to heat it slightly. Warm it in fact. Not heat it because alcohol is, this is sample which is alcohol for us. It's inflammable. So you will be heating in water bath. This is very, very important, children. Please do not make this mistake. So heat it in water bath. Water bath, you'll keep water and heat water and then keep the test tube in that water. Okay, so indirectly you are heating it. On heating for some time, you do not heat directly. That also you have to keep in mind, right? So after heating for some time, you take a beaker and whatever contents were there, this you have taken, these things you have taken in test tube. After heating for some time on water bath, pour it in a beaker which is containing water. This is having water. Pour this content in water and you smell it. You smell it, you will get fruity smell. Fruity smell will be obtained. The presence of the fruity smell indicates that alcohol is present. It will confirm that alcohol is present in our, sample, organic sample. Right. Suppose alcohol is not there. You will have to write down negative test. You can write one negative test. Then you needn't write, both the tests. You can just write sample plus can, then no characteristic color obtained, alcohol is absent. If you are getting alcohol, you will write down both the tests. If you are not getting alcohol, you will write down can test, absence of the no color obtained, alcohol absent. Okay, then the second functional, this was the first one. You are always going to start with alcohol. The second functional group which you are going to try for is phenol. Phenol is C6H5OH. Okay, how you are going to perform the test? Let me explain. Now for phenol, again there are two tests. One test is ferric chloride test. So what you can do is, you can take sample, that is phenol for us. The solution you can prepare. It's actually crystals, but that is, heated and then you get it in the form of the liquid. So this plus ferric chloride, neutral ferric chloride. It's neutral ferric chloride we are going to add. What you will get is violet color. The presence of violet color indicates phenol is present. Okay. The violet color will confirm in fact this phenol is present. Okay, so if it is phenol, you will write alcohol, can test absent, can test negative test you are going to show, and so phenol is alcohol is absent. Then you are going to confirm phenol if it is phenol. The first test is ferric chloride. If you get ferric chloride test, then you can perform the second one. Otherwise, you can say phenol also absent. Okay, if you are getting ferric chloride test, what you can do is you can start with the next one, that is Lieberman's reaction, Lieberman nitroso test. Okay, that test you can perform. So what is that test? Let me explain. What you do is, you take in the test tube the sample, which is phenol for us. To that, you will add NaNO2. NaNO2 solution. You are preparing NaNO2 solution. You're adding it. And then you are adding to this sulfuric acid. You will add sulfuric acid, H2SO4 dilute sulfuric acid you will add. So what you will get after adding sulfuric acid is deep blue color. Deep blue color. Bluish color also you can say. This you will get. To this now you add water. On adding water it will turn to red. Then to that red color you will add NaOH. On adding NaOH, again it will become deep blue. Okay, plus the equations also you have to learn. Equations, children, you can learn on your own. So this I am just telling you how you have to perform. Right? So if you get ferric chloride positive test, you go ahead with Lieberman test. Sample solution, NaNO2. Then you can directly, because it's liquid, you can add NaNO2 crystals also in it. So this you can add sulfuric acid, you'll get deep blue. Add water, you'll get red color. To the same you are adding, same test tube, you're not washing the test tube here in between. So that to the same again you add NaOH, you will get deep blue. This is Lieberman nitroso test. Suppose you got phenol also absent, you will do this, ferric chloride, no characteristic color obtained, phenol absent. Then you go ahead with the third one. Right, the third test is for actually aldehyde. So the test which we are performing here is carbonyl compound test, carbonyl group presence test we are doing. Right, so how you do this is, you take sample plus 2,4-dinitrophenylhydrazine. Do not make mistake in this naming. It is 2,4-dinitrophenylhydrazine. Normally children make mistake. They say 2,4-dinitrophenol. It's phenylhydrazine. Okay, so this you are adding to the sample. On adding 2,4-DNP, you will get orange PPT. You will get orange PPT. Now the presence of the orange PPT indicates carbonyl group is there. So carbonyl group mein you have two functional groups, aldehyde and then you also have ketone. Okay, if you get this orange PPT, you will have to go for aldehyde or ketone test. If you do not get orange PPT, you will say carbonyl group absent. That means aldehyde, ketone both will be absent in that case. Okay. Now suppose you get a PPT, you got a orange PPT, you will say carbonyl group is present, CO group is there. Now let us confirm for aldehyde or ketone. Okay, so you will take whatever solution you have. With that, first you are going to try for aldehyde, right? If it is aldehyde or ketone, you will have to check for that, right? So first you try for aldehyde. So what you do is, you will have a sample. To the sample you add Schiff's reagent. You add Schiff's reagent. On adding Schiff's reagent, what you get is pink color or magenta. We call it as magenta color. Magenta color is obtained, indicates the presence of aldehyde. Okay, if you get this, aldehyde is present. But do not rely only on this, because at times even ketone is giving Schiff's test. While writing, you will say pink color is given, aldehyde is present. But in case you want to confirm that it is aldehyde or ketone, you better perform two tests for ketone. One test for ketone is sample solution. Whatever sample you have, it's in the liquid form, so sample itself, plus 2,4-dinitrobenzene. No, not 2,4, sorry. It's meta-dinitro. It's meta-dinitrobenzene. Meta-nitro. So it's just meta position. No need to write down di also. Meta-nitrobenzene. Meta-nitrobenzene. So sample plus meta-nitrobenzene. Meta-nitrobenzene means it's not 2,4. Please make that correction. Meta-nitrobenzene means at meta position two nitro groups are present. Meta-nitrobenzene is added, plus base is also added. NaOH will be added. On adding here, you will get violet color. The presence of violet color will indicate that a ketone is there. Okay, so for ketone there are two tests. One is this sample plus meta-nitrobenzene. Okay, so you will add base to it, you will get violet color. The second test is, you will add to the sample sodium nitroprusside. Sodium nitroprusside you will add, along with base again, NaOH you will be adding. What you will be getting is red color. It's literally blood red color which you get. So if you get that color, it indicates that ketone is present. Okay, suppose it was not giving 2,4-DNP test, you will say carbonyl group absent. That indicates aldehyde, ketone both are absent. If you get this orange PPT only, you will go ahead with aldehyde or ketone. Okay, suppose you do not get this, also you will go for the next functional group. The next functional group is carboxylic acid. Carboxylic acid is COOH. Now how you perform for this is, again there are two tests for this. One is ester test, which already I told you. Ester test. Now in that case our sample was alcohol. Here our sample will be carboxylic acid. To this sample you will add alcohol, plus you will add few drops of dilute sulfuric acid, and then you are going to heat it on water bath. On heating in water bath, you will pour it in a beaker containing water. You will get ester smell. Smell you will check. Okay, that is fruity smell. So the presence of the fruity smell will indicate that acid is present. Okay. Yeah, here concentrated sulfuric acid you will add. Concentrated. Few drops of concentrated sulfuric acid. Okay, sample alcohol, few drops of concentrated sulfuric acid, then fruity smell you will get on heating. Okay, so even in that alcohol, you can make this correction. This is concentrated. Few drops of concentrated sulfuric acid you are adding to get that, fruity smell. Okay, so this is one test you are doing for carboxylic acid. The second test which you are performing for this is sodium hydrogen carbonate test. You will take sample. To that sample, you will add sodium hydrogen carbonate. On adding sodium hydrogen carbonate, there will be brisk effervescence. Brisk effervescence. Okay, brisk effervescence is due to the liberation of carbon dioxide gas. This is evolved. This indicates, the presence of carboxylic acid. This you also study in theory. Sodium hydrogen carbonate test for carboxylic acid. Got it? Now the next functional group which we have to perform is amine. Amine is that NH2 group. There is only one test for it, that is azodide test. Azodide test. Okay, azodide test. Now how you perform that is, you will take 3 test tubes, A, B, C. Just in your mind you remember there are 3 test tubes. In the first you are taking sample. Right? In the second test tube you are taking NaNO2 solution. In this sample you have added little. In this sample what we will do is, we will add little quantity of dilute HCl. Why do we add? Because if I take sample solution, then aniline is not water soluble because of that hydrophobic ring part. It's not soluble in water. You'll take a solution and add little dilute HCl. This is test tube A. In test tube B, you'll prepare NaNO2 solution. NaNO2 solution. In the third test tube, you will take beta-naphthol plus NaOH. Right, so what is beta-naphthol? Naphthalene. Naphthalene is this. 2 benzene rings fused together is naphthalene. So this is alpha, this is beta. At the beta position there is OH group. So beta-naphthol. Okay, beta-naphthol plus NaOH you will take in the third test tube. So all these 3 test tubes you will keep in ice, so as to maintain 0 to 5 degrees Celsius. If you remember that these in Sandmeyer's and we have already done that in diazotization the temperature has to be maintained 0 to 5 degree. So we'll keep these in ice bath, and then you will first mix A and B. The purpose of mixing is, this is containing aniline, that is C6H5NH2. NaNO2, HCl, they will form diazo, that is N2Cl, and then it will combine with this aniline and it will result in the formation of that C6H5N2Cl, that is diazonium halide. So first thing is, you cannot take HNO2 as such in the lab. So you are mixing NaNO2 and HCl there and then to form HNO2, and that HNO2 will now combine with aniline and will result in the formation of the diazonium C6H5N2Cl. Now A and B you mix, and then you add this combination of A and B to C. Right? A and B you have to mix first so as to prepare diazonium. Then you will add it to C, that is beta-naphthol and NaOH mixture. What you will get is orange color dye. You will get orange color dye. So this indicates the presence of amine group, NH2 group. Fine. So this is the last functional group. This you will be getting in case you did not get the previous one. Okay, so the order is alcohol. If you get alcohol, you needn't write any other. If you do not get alcohol, you will write alcohol can test negative. Then you'll go ahead with phenol. This is what I showed you here. Okay, so if you get this, fine. You have to perform the second one also. If you do not get, this is negative, you go for phenol. Phenol, you try ferric chloride first. If you get, you go for Lieberman also. In case you do not get phenol ferric chloride, you will write phenol absent. Then you go ahead with 2,4-DNP. If you get 2,4-DNP, you will say carbonyl group present. Then you can go ahead with aldehyde or ketone. In case you do not get this orange PPT, you will say aldehyde ketone also absent, no carbonyl group present. Then you have to go ahead with the carboxylic acid. right? And then finally amine. Clear? So please learn well. Okay, so I hope the video is useful to you. Thank you.